The objective of this simulation is to try and make mass balances more visual for the case where we start out with a single component in vapor-liquid equilibrium. So that's what's represented here on the left. The mole fractions of liquid phase 0.35, vapor phase 0.76. And what we're going to do in this case is add just component A to the system. And what we want to demonstrate is it's possible to add component A and still end up with a vapor-liquid mixture with the same mole fractions in each phase. What we've done is change the relative amounts of vapor and liquid. And so the idea of the mass balance, and you'll notice I'm indicating that we're adding A in the vapor phase. And I'm doing that because I already know what's going to happen in the final condition. I'm adding the more volatile component, I'm going to end up with more vapor. In order to have this happen and keep the mole fractions the same, what's going to happen is some fraction of the liquid's going to evaporate. And so some liquid remains. This fraction that evaporates has to have the same composition as the original liquid. In other words, the mole fraction is 0.35 for that vapor. Otherwise, we would have changed the liquid composition. And we're going to take this evaporated vapor, mix it with the pure component, such that when they mix together, they have the same mole fraction that we started with. And then, of course, these two vapors, our original vapor plus the additional vapor we created when we added A, have the same composition, so they end up in the vapor phase. We've kept the liquid phase composition the same, we've kept the vapor phase composition the same. So the important thing to remember here is the size of these rectangles represent the amounts of the phase. If we now look at a PXY diagram, we can understand why this takes place. So this is the pressure mole fraction of A diagram for the same system that showed the visual representation of mass balance. This is our starting point. We add some A, but we're at constant pressure, so we have to be on a horizontal line. We're at constant temperature, so it means we stay on this diagram, since this entire diagram is at one temperature. And you can see we've moved to the right to more vapor, less liquid, but we have not changed the mole fractions. If we were to add enough A, we could end up out here with a different overall mole fraction and only vapor phase present. And so when we look at the simulation itself, we can see what this behavior is like. So here we're looking at the interactive simulation. And in this case, we'll step through the process. So the number of moles that we're adding, we select it with this slider here. Let's keep it at 1 mole. And then the animated slider will step us through the behavior. So we're starting out with liquid and vapor. We're adding pure A. And as we move the slider, it shows that we're evaporating some of the liquid in the correct proportion, so the liquid that remains has the same composition. And then as we continue to animate, you notice what we're doing is mixing the pure A that we added with the evaporated, the original liquid that evaporated. They each have the same mole fraction, so we combine those two vapors. We end up with two phases in equilibrium with the same mole fractions, but different amounts. And if we look at the PXY diagram, we can see the black dot is where we started, the green dot is where we end up. If we add more moles, we have more and more vapor, but we can reach a point where we add enough moles. Now we only have vapor, and now we can change the mole fraction. And of course, we can do the opposite. We can, let's go back, start with the black dot, add component B. This is going to increase the amount of liquid, the blue dot. And if I add enough of B, I'll go into the all liquid phase. And then the simulation shows the same type behavior, except if we're adding B. And we can start and then animate to lead us through. Where now we add B, we condense some of the original vapor. And as we lead through, we end up with the same overall mole fractions, but now more liquid and less vapor.